In the last video, we saw how to find the number of zeros at the end of 173 factorial. We added this 34, 6 and 1 and got that there will be finally 41 zeros at the end of 173 factorial. But interestingly, there is one more way to arrive at the result that we obtained here, 34, 6 and 1. And let's see what that is. So if I'll take 173, and divide that by 5. So let me see what quotient do I get here. So 5 3s are 15. When I'll subtract them, I'll get 2. 3 will come down. 5 4s are 20 and I'll get 3 as a remainder. And that is actually logically what we saw here. We'll have 34 5s. The numbers that are divisible by 5. So this 34 we can actually see that I got as a quotient here. Another interesting thing is, if we will divide this quotient that we obtained here, this 34 again with a 5. Let's see what result do we have here. Now 5 6s are 30 and the remainder is 4. So this 6, the extra 5s that we got because of the multiples of 25, this 6 I'm getting as a quotient when I'm dividing the quotient that I obtained here, 34, again with a 5. And similarly this 6 here, if I'll divide this quotient that I obtain here with a 5, I'll get 1 as a quotient and 1 as a remainder. So this one that I have because of 125, this one extra 5, I'm getting as a quotient here. Now when I'll add all these quotients, 34 plus 6 plus 1, I'll get 41 as my answer. Now I cannot go further because 1 won't be divisible by 5. So I'll just leave it here. I'll just not go beyond this. But I can clearly see that whatever the number given in the factorial is, just start dividing it by 5, and whatever the quotient you obtain, that will represent the number of times 5 you will obtain. Again divide that quotient with one more 5, you will get the number of extra 5s you will get because of 125. Again divide this quotient by 5 and you will get a number of extra 5s you will have because of 125. Let's assume that if instead of 1 as a quotient here, if suppose the quotient was, let's say 7, let's say the quotient was 7, then I would have again divided this 7 with a 5. Again I have divided this 7 with a 5, and in this case I would have again obtained 1 as a quotient. Now this 1 will represent the extra 5 that I'll get because of 625. 625, 5 times 5 times 5 times 5. Because up to 125 it was 5 times 5 times 5. Up to 25 it was 5 times 5. Up to 5 is just single 5. So you have to do that until you reach where the quotient will be 0 itself. So actually here it was 1 itself, fine. So just divide the quotients with 5 and add them all together to get the number of zeros at the end of any factorial that is given there.